ML engineers kick off a project by understanding its requirements. This crucial first step involves working hand in hand with stakeholders, such as business analysts and domain experts. Together, they define the project's objectives, identify data requirements, and set expected outcomes. It's a stage filled with probing questions and deep discussions, all aimed at gaining comprehensive insights into the problem domain. A clear understanding of the requirements lays the foundation for the subsequent stages of the ML project. With a firm grasp on the requirements, ML engineers move to data collection and preprocessing. They gather data from a variety of sources such as databases, APIs, and external datasets. The data, however, is often raw and messy. Therefore, it undergoes a cleaning process, handling missing values and removing duplicates. Additionally, data transformations are performed to make the data suitable for training machine learning models. Clean and pre-processed data is the key to effective machine learning. Next in the workflow is feature engineering and model selection. Feature engineering is all about selecting and creating the most relevant features from the raw data. Think of these features as the key ingredients in our machine learning recipe. They help us effectively represent the underlying patterns and relationships in the data. Techniques like one-hot encoding, feature scaling, and dimensionality reduction can be used to prepare the data for modeling. Now let's talk about model selection. This is where we evaluate different machine learning algorithms based on our project's requirements, data characteristics, and desired outcomes. It's like choosing the right tool for the job. We might consider factors like accuracy, interpretability, and scalability to choose the most appropriate algorithm. The right features and the right model set the stage for effective machine learning. With the right data and model in place, it's time for model training and hyperparameter tuning. Model training involves feeding our selected model with pre-processed data. This allows the model to learn and understand the patterns and relationships within the data, making it capable of making accurate predictions or classifications. But hold on, our work doesn't stop at just training. We also need to optimize the model's performance through a process known as hyperparameter tuning. This involves adjusting certain parameters within the model to make it not just good, but the best it can be at its task. Think of it like fine-tuning a musical instrument to get the perfect sound. Hyperparameters could be the number of layers in a neural network, the learning rate, or any other factor that is not learned from the data during training. We perform a search over a range of hyperparameter values, selecting the combination that yields the best results. A well-trained model with optimized hyperparameters is a powerful tool in machine learning. After training and tuning, the model is ready for evaluation and deployment. Evaluation occurs on a separate validation or test dataset, providing a robust measure of the model's performance. We use key metrics like accuracy, precision, and recall to assess effectiveness. With a successful evaluation, we progress to deployment. This means the trained model is integrated into a production environment, ready to tackle real-world scenarios. A model that has been rigorously evaluated and successfully deployed is ready to make real-world impact. The ML engineer's job doesn't end with deployment. Monitoring, maintenance, scaling, and iterative improvement are crucial. Once an ML model is in the real world, it's vital to keep an eye on its performance. Are the predictions still accurate? Is the model behaving as expected? If there are any hiccups, it's back to the drawing board, troubleshooting and retraining as necessary. This is the essence of monitoring and maintenance. But what happens when the data volume grows or user demands increase? That's where scaling comes in. ML engineers may explore techniques like distributed computing or hardware acceleration to ensure that the model can keep up with the pace. And let's not forget about the power of iterative improvement. The ML workflow is a cycle, not a one-way street. ML engineers continuously refine their models, incorporate fresh data, adapt to changing business needs, and strive for that ever-elusive perfection. Through diligent monitoring, maintenance, and iterative improvement, ML engineers ensure that their models continue to deliver value over time. Throughout the entire workflow, collaboration is key. Machine learning engineers, data scientists, software developers, and domain experts all bring unique perspectives and expertise to the table. Together, they navigate the complexities of the project, find innovative solutions, and ensure the final product aligns with the organization's strategic vision. The impact of their collective work is profound, transforming raw data into actionable insights and driving efficiencies across the business. By working together, these professionals deliver ML solutions that drive tangible business impact and add value to the operations.